This video showcases my cloud engineering skills by fine-tuning and improving API performance on AWS. Two common methods to improve API performance are caching and compression. By default, user requests hit the back end to retrieve data. The use of caching keeps data copies at edge locations, reduces requests sent to the back end, and eventually lowers latency. In my application, the caching techniques include defining CloudFront cache behavior to cache specific request methods, enabling method-level caching at the API Gateway stage, caching query string parameters for each API Gateway resource, Another method to improve API performance is compressing response data to decrease API response size, lower bandwidth usage, increase API throughput, and eventually reduce latency. I designed and implemented performance tests for the API. Two API are deployed, the baseline without performance tuning and the improved with caching and compression. Both API share the same architecture and are tested with Grafana K6. A comparison threshold is used. Error rate should be less than 0.01 and P95 latency should be less 500 milliseconds. The test results indicate that the baseline API failed due to breaching the threshold. The improved API passed with lower response times. To investigate the failure, I compared the K6 results and the API Gateway dashboard. found the primary cause was 5x errors breaching the HTTP failure thresholds. Similarly, I deep dived into the Grafana dashboard to understand why the improved API passed. Found that most requests were served from cache, with fewer back-end calls leading to lower HTTP failure rates and latency. Thanks for watching. This video showcases my cloud engineering skills by fine-tuning and improving API performance on AWS.